Step number 5 is to determine the breakaway point. What's a breakaway point? So let me go back to this root locus, which is the root locus of the same function that we've been discussing. So the breakaway point basically is, let me make this a little larger. Okay, so now when you have a set of root locus on the x-axis, and if you keep increasing the value, and if it breaks away from the x-axis and go in x and y domain, that is, the system is becoming now critically damped system because it will have complex conjugate roots. This point where the system leaves the x-axis and then start moving in xy plane is called breakaway point. So that's the breakaway point. How do you find this point? We find this point by using 1 plus kps is equal to 0, which is our basic equation. 1 plus kgs or kps is equal to 0. Kps is -1 and k is equal to -1 over ps. And we call this lowercase ps. So breakaway point will be when you take the derivative of dk over ds or d lowercase ps over ds and equate it with 0. That is the slope of the equation when it will become 0. That's how you're going to find the breakaway point. So let's look at this example. It's not the same example. Let's look at this example. 1 plus k s plus 1 or s plus 2 s plus 3. So we have 1 0, -1 and 3 poles at 0, -2, -3. That's our first step. So -1, 0, and then 0, -2, -3. Second step, what will be the sections of x-axis that will be part of your root locus? So this section, of course, because you have one pole on the right side, odd number, this will not be part of the root locus because you have 2, 1, 0, 1 pole. This will be part of root locus because you have 1, 2, and 3. And then beyond this x is equal to -3, there will be no root locus because now you have 1, 2, 3, and 4 total roots plus zeros. So these will be part of root locus. That is step number 2. Step number 3 is to find the centroid. That is where there will be asymptotes located or along where there are asymptotes along which the zeros at infinity will be located. So since we have 3 poles and 1 0, that means 2 zeros will be located at infinity. And for those 2 0, first we're going to find out the centroid, that where will be the intersection of asymptotes with respect with x-axis. So that's going to be sum of all the poles, -2, -3, which is -5, minus sum of all zeros. There is 1 0, -1, so negative of -1 plus 1 over 2. So -2 is the centroid. -2 right here is the centroid. And then what will be the angle along which those zeros will be located? So we're going to calculate the angle, 2k plus 1 over 2, and since we have 2 zeros, k will be 0 and 1. So when we put k is equal to 0, that's going to be 180 by 2, 90 degrees, and when we put k is equal to 1, it's going to be 270. So the asymptotes will be vertical, which will be going through the centroid -2. Now, where will be the breakaway points? That is where actually before that, if it will be intersecting the x-axis, the imaginary axis or not. Well, since you have asymptotes at 90 and 270, there is no way that it is going to intersect the y-axis. So really there is no point of doing that step because your zeros are located here and this is your centroid. That means your zeros, for zeros, the curve is going to go from here, right here. So it will not intersect this. It's just going to go along this line. So we don't have to do that step. So the next step is going to be to find the breakaway point. And to find the breakaway point, as we discussed here, dk over ds equals 0. And k is equal to -1 over ps. And remember, this is our ps, s plus 1 over s, s plus 2, s plus 3. So k is equal to -1 over ps, which is negative of denominator over numerator. And we differentiate this k with respect to s. We get this. We equated it with 0. And then we're going to get 3 roots. Of course, a cubic equation, cubic polynomial. We get 3 roots. S is equal to -2.46, and there are 2 complex conjugate roots. Of course, complex conjugate roots is not our answer, because we are trying to figure out the point on the x-axis that is the breakaway point. So the point on the x-axis is -2.46. Hence, the point is -2.46. I put down -2.5 approximately, but -2.46 over here. So this will be the breakaway point, and the curve is going to be something like this. It has to go along this line. It's going to break away from here, so it's going to go something like this approximately. I'm doing it approximation over here. Of course, actual curve, of course, we can draw always using MATLAB. That will be your project actually. So that's how we're going to find the breakaway point on the x-axis.